Good day and welcome to today's class. Today's class is a continuation of our previous classes on set theory. In today's class, we shall be discussing Venn diagram. We shall discuss Venn diagram and its application up to 3 set problems. Venn diagram can be defined as the pictorial representation of sets. Sets can be represented diagrammatically by closed figures. Venn diagram was introduced by John Venn. The operations of intersection, union, and complement of sets can be represented using the Venn diagram. The operations of intersection, union, and complement of sets can be demonstrated easily by the use of Venn diagram. In today's class, learners will know how to draw, interpret, and use Venn diagrams in solving problems. Let's look at the Venn diagram. Just like I told you in our previous classes, that the universal set can be described using or represented in Venn diagram by the use of either a square or a rectangle. This can be used to demonstrate the universal set, while the subset, which are part or fractions of the universal set, can be described using a circle or an oval shape. So we shall be looking at how these can be used in solving problems. If we have a universal set and a 2 subsets, A and B, with an intersection, it can be demonstrated this way. If this is set A and this is set B, since they are part or fraction of the universal set, they can easily be represented this way, where we have, I'll call it 4 regions. We have region 1, region 2, I'll call this region 3, and region 4. I shall be explaining the various regions of this set. Region 1 can be said to contain elements that you can find both in A and B. So this region 1 is said to be a region that carries elements you can find only in A and B, and this can be denoted as A intersection B. While region 2 is said to be a region that contains elements only in A. That is, elements you can find only in A is said to be in region 2. And that can be represented as A intersection B prime. B prime in the sense that you can't find those elements in A, but you can find them. You can't find those elements in B, but they can be found in A. Region 3 is said to be a region containing elements that can be found only in B, and this can be written as A prime intersection B. Region 4 is said to be made up of elements that are neither in A nor B, but are in the universal set. So this region, the whole of this region, is said to be made up of those you can find only in the universal set, but not in A or B. So we refer to these as bracket A union B or prime. So these are the regions. Also, region 1 plus region 2 can be said to be elements you can find in A, while region 2, 1 plus region 3 can be said to be elements you can find in B. If you add up region 1, 2, 3, we refer to them as the union of A and B. That is, A union B is said to be equal to region 1 plus all in region 2 plus all in region 3. While region 4, I said, is A union B prime. For a 3 subset problem, this can be represented this way, where we have set A, set B, and a set C. If I call this A, B, and C, why this is said to be the universal set. And the universal set is said to be a sum total of all the regions we have here. For example, in that of the two subset problem, the universal set can be said to be equal to the sum total of region 1 plus region 2 plus region 3 plus region 4. So our advice, you keep this in mind, because this will be used in solving problems on set. So for a 3 subset problem ABC, this can be considered to be divided into region 1, region 2, region 3, region 4, 5, 6, 7, and 8. I will be defining each of these regions for us. Region 1 is said to contain elements you can find both in A, B, and C only. Elements that are in A, B, and C. And in set notation, we can describe this as A intersection B intersection C. Remember, I told you that Venn diagram is used in demonstrating the union, intersection, and complement of sets. Region 2 can be named to be elements you can find only in A and B. If you look at region 2, is this. Let me shade it. This is region 2. It means that it contains elements only in A and B. You can't find elements in C on it because the boundary of C does not fall in that region. So we have this to be A intersection B intersection C prime, meaning it can be found only in A and B. While region 3, I will take that of region 2 again. Region 2 is said to contain elements you can find only in A and C. So the prime should be for B. So B is the complement. While in region 3, it contains elements only in A and B. And this can be written as A intersection B intersection C prime. Region 4 can be said to be a region containing elements in B and C only. So this is also written as A prime intersection B intersection C. Region 5. In region 5, we have elements that can be found only in C. Only in C. So this can be written as A prime intersection B prime intersection C. While region 6 can be described as region where you have elements only in A. So this is written as A intersection B intersection C prime. So B and C are primed, while region 7 contains elements you can find only in region B, and this can be written as A prime intersection B intersection C. For region 8 is said to be a region that contains elements you can find in the universal set, but you can not find them either in A, B, or C, in any other region. So they can only be found in region 8. That is the universal set. And we write these using the set notation A union B union C or prime, meaning they can not be found in either A, B, or C. So this is how they can be represented. I have explained the different regions in a tree subset problem. Before we wrap up this class, I would like you to note that the sum total of all the regions in a tree subset problem gives you the universal set. That is to say, region 1 plus region 2 plus region 3 plus region 4, 5, 6, 7, and 8 gives you the universal set. Remember, region 1 contains elements you can find only in A, B, and C, while region 2 contains elements you can find only in A and C. Region 3 contains elements you can find only in A and B, while region 4 contains elements that can be found only in B and C. Region 5 is said to be element found only in C, while region 6 is said to contain elements found only in A, as region 7 is said to be elements you can find only in B, while region 8 are said to be elements that can be found in the universal set but cannot be found in A, B, or C. Region 7, we said elements found only in B, so this should be primed. Okay, so that brings us to the end of today's class. In today's class, we have learned how to draw and interpret the different regions in a Venn diagram. In our next class, we shall see how we can use Venn diagrams in solving word problems. Thank you for being patient to the end of this class. Kindly like our videos if you have not been doing that while you watch. Comment and also share the videos to your friends and families who may need such. Thank you and do have a nice day. See you tomorrow.